Fraction equivalent research, page 1. Okay, you can see at the top we've got 1 equals, and then there's a fraction line there, and then equals and a fraction line, and equals and a fraction line. What we do is we're going to write all the equivalencies, okay? So 1 is equivalent to 2 over 2, which is equivalent to 3 over 3, which is equivalent to 4 over 4, 5 over 5, 6 over 6, 7 over 7, 8 eighths, 9 ninths, and 10 tenths. That's what these circles are, right? This is 5 fifths, 6 sixths, 7 sevenths, 8 eighths, and so on and so forth. And they all are equivalent to 1, okay? So then we go to 1/2. Now, if I were doing this with my students, I would have them use the circles to validate, you know, what they think. After I've shown you everything, hopefully you will remember that 1/2 is equivalent to 2/4, which is equivalent to 3/6, which is equivalent to 4/8, which is equivalent to 5/10. You could just do up to our fraction circle 10 family, okay? 2 over 2, well, that's just equivalent to 1. So you can see they're going in families here. So here's a family, here's a family, here's a family, here's a family, here, and here's a family, and you get it. So here's the 7th family, here's the 8th family, here's the 9th family, and here's the 10th family. Okay? So 1/3 is equivalent to 2/6 and 3/9. It's just like what we wrote in our book, isn't it? And 4/12. You can keep going if you want to. We've got 5/15. You don't have to, but that's what you can do if you want to do that. Well, 2/3, well, that presents a different problem, doesn't it? Well, now we're counting by 2's on the numerator, aren't we? So 2/3 means, well, if 1/3 is equivalent to 2/6, then 2/3 would be equivalent to 4/6. Okay, let's just make sure. Let's find out. So here's our 1/3. Here's our 6ths. So here's 1/3, but here's 2/3. So if 1/3 fits into if 2/6 fit into 1/3 space, wouldn't 4/6 fit into 2/3 space? Why, yes, it does. So 1/3 equals 2/6, 2/3 equals 4/6, right? Easy peasy. So 2/3 equals 4/6. Well, if we're counting by 2's now, 2, 4, 6, and we're counting by 3's down here, 3, 6, 9. That means 6/9 would fit into 2/3. Shall we check to be sure? Here's our 9ths. 1, 2, 3, 4, 5, 6. Our theory is correct. So if we have to count by 2's on the numerator, and we're still counting by 3's on our denominator, what would our next fractional equivalency be? 2, 4, 6, 8. Count by 3's down here. 3, 6, 9, 12. Can you see that? We have found the pattern, haven't we? This is what leads children to be able to reduce fractions easily. And then when we tell them the rule for finding the common denominator later, after they've done all this work, the rule becomes easy to digest. So we could keep going, right? 2, 4, 6, 8. What is the next one? 10. 2, 4, 6, 8, 10. 3, 6, 9, 12, 15. Okay. Again, this is why we need to know our multiples. We need to know our skip counting. Now we're down at 3/3. Well, 3/3, there's 3/3. What's that equivalent to? 1 whole, right? Okay, now we're on our 1/4. 1/4 is equivalent to 2/8. We already learned that. And 3/12 and 4/16. What about 2/4? 2/4, we know we could reduce down to 1/2, right? Because look, there's our 2/4. 2/4, we can write 1/2. And we could just even stop there if we wanted to. Because really, what are we trying to do? We want to understand how to reduce. That's why we're doing this. So we could write 1/2 and then just stop. Or we could keep going. 2/4 is equal to 1/2, which is also equal to 2/4, which was equal to 4/8, which is equal to 2, 4, 6, we could do 6/12, yeah. 6/12 and 8/16, yada yada, you get it. Now 3/4. Okay, so we found the pattern. We're gonna be finding the multiples of 4 on the denominator, but now it's the multiples of 3 on the numerator. So let's do our denominator first. Let's write all of our fractional equivalencies with the denominator. So if we're skip counting by 4s, we're going to say 4, 8, 12, 16, 20, 3, 6, 9, 12, 15. Okay. 4/4. 4/4 equals 1. 1/5. I don't think we need to do them all again, do we? So if we're counting by 5s on the denominator, and then we're going to count by 1s on the numerator. So 5, 10, 15, 20, 25. Count by 1s on the numerator. 1, 2, 3, 4, 5. For 2/5, though, we're going to count by 2s on the numerator. Let's do the denominator again. You should all be able to count by 5s. 5, 10, 15, 20, 25, 2, 4, 6, 8, 10. These are all equivalencies. 3/5. We still count by 5s on the denominator, but now in the numerator, we're going to count by 3s. Let's make our fraction equivalency numbers here. 5, 10, 15, 20, 25, 30. Now let's count by 3s on the numerator. 3, 6, 9, 12, 15, 18. So these are all equivalent. 15/25 is the same as 3/5. Now 4/5. So notice the pattern. We're still going to count by 5s on the denominator, but we're going to count by 4s on the numerator. I can't hammer this home enough times. We need to know our multiples. 5, 10, 15, 20, 25, 30. Multiples of 4. 4, 8, 12, 16, 20, 24. That's what we're going to do for the whole page. Okay, so all the ones, though, that you see that are 7/7, 1. 6/6 is equivalent to 1. 9/9, that's equivalent to 1. 10/10, that's equivalent to 1. Oh, here's 8/8 is equivalent to 1. All right. If you've come to fractions that you know you can reduce easily, go ahead and reduce them. So like, remember when we got to 2/4? I wrote 1/2. We don't need to actually keep writing the rest of them, because really my goal for you is to know your fractional equivalencies, but also know how to reduce. So like you could say, oh, 5/5 is 1. 2/6 reduces to 1/3. And you can leave it at that. 3/6 reduces to 1/2. You can leave it at that. What does 4/6 reduce to? 4/6, you could reduce that, right? If we had 4/6, what is that the same as? What did we learn over here? Oh, it's the same as 2/3. Could we just reduce that to 2/3? Yeah. We could keep going the other way too. But if you would rather just write the reduction, that's okay. But then for the smaller fractions, go ahead and, or the smaller numerators, go ahead and write your equivalencies, just so that you're getting that kind of stuck in your head, okay? But I do see like, okay, 4/8, boom, that we know that's 1/2. 5/10, we know that's 1/2. Right, does that make sense, everybody? If you have any questions about this, go ahead and shoot me an email. But just try your best and have fun doing your multiples, and then recalling back to your books here and seeing how you can reduce. Okay, they all go hand in hand, and they are designed to help just develop the mathematical mind. All right, have fun. Bye.